Welcome to my channel. Let's start with the what is sorting. When we try to sort something, we need to arrange the data into some order. In the earlier classes, you have studied about ascending order and descending order. It is similar to that. But now we need to code for that, and we have so many sorting techniques. And today we will be discussing selection sort. So we are given an array 12, 1, 21, 15, 13, 0, minus 3. And we need to sort it. You can easily try out to sort these elements by using your copy pen, but now we need to observe the pattern. What selection sort algorithm tell us to do? Firstly, we need to find out the minimum element by traversing a whole array and swapping the element with the first element, with the current element, with the number of iteration which the let's see the first element is 12, and now we are comparing it with 1. Yes, 1 is smaller than it. Then we will update the minimum as 1, and we will denote it by red color. And then we move to 21, and as we know 21 is not less than 1, so we will move ahead. And then 15 is also greater than 1, so we will not change the minimum. Then next, still 13 is greater than 1. Then 0, it is less than 1, so we will change the minimum to 0, and we'll move to minus 3. And then we know minus 3 is smaller than 0, so again we swap minimum as minus 3, and then we swap with the first element. So this is the first iteration. Now our first element is sorted. Now we will move to the second element. So now we have second element as 1. For now we will compare it with 21. As we know that 21 is greater than 1, so we will take 1 as minimum, and we will move ahead. Then 15 is still greater than 1, so we will move ahead. 13 is greater than 1, we will move ahead. Then 0 is less than 1, so here we will change the minimum to 0. And then 12 is greater than 0, so we will not change the minimum and just swap with the second element. And then we have fixed two numbers. Now we will search for the third number. Now minus 3 and 0 are sorted. Now we are moving ahead. Okay. So here we have 3 elements sorted. Now we will start with 15. Okay, now we have 13 as the fifth element, and now we are comparing it with all others. And in this case 13 is the smallest, so we don't need to swap. And that is all. Our array is sorted, so we are done with the algorithm. Now we need to see the implementation, but before that I would suggest you to write the code yourself. So let's start with the implementation part. So we have this array, so we need to apply selection sort. So I will be using Visual Studio Code, and you can use anything which you are comfortable with, and we'll be creating a file selection sort.cpp. So I have selection sort, and I need to have the basic code so that we can implement cpp file using namespace standard int. So that is return 0. And now we are having the array int arr, and we'll be using square bracket for declaration initialization, and we'll be copying the array from here and we'll make the array. Now we will be calculating the size of array. How we will calculate the size of array? So basically we have 7 elements and we need to calculate the size of array. So we are using a inbuilt function size of and will be passing the size of function the array, and in size of function what it is doing is that it is returning the value of size value of array, value of size of array and we are returning size of int, and then here we can do int also, and also we can do array of 0. To be more precise, array of 0 will be the perfect one. So let's start with it. So now we have the size. The thing what we need to do here is to create a function above there named void print, which will take one array as an argument and one size as an argument. And what we need to pass here is that we need to pass print arr n, and here we will write the simple code so that we can understand this easily. R array before sorting. So I think so it is pretty much clear that we are printing the array using this print function. So let's start with the for loop. Int I is equals to 0, I less than n, I plus plus, and then we will be see out array of I, and will be having some space, and in last we will having some see out. And so this is the whole stuff. And now what we will do is that here we will write see out our array after sorting. So this will be array after sorting, and we will be printing again by using the same arguments, as we need to print the same array. So now we will be writing the selection sort method here. Selection sort, and here also we need to pass array and n as an argument. And let's start with it. Void selection sort int array int n, and then we were traversing whole array so as to calculate the numbered maximum minimum. So we will be finding the minimum and the element which should be there by having this for loop, and then we will be having smallest is equals to firstly we are allocating it as array of I, that if nothing is there then it will not swap it, it will just say that it is array of I, so I don't need to swap. So then we were having smallest or small index, so that would be I. Then we are having j is equals to I, j less than n, j plus plus, and then pretty much we can do if array of j is less than smallest, we will we will store smallest, we will store array of j in smallest, so that is it. And after it we will say small index should be equal to j now. Okay, so after this whole loop we will getting the minimum element which will be stored in the small index, and we will need to swap it. We can use here the basic array manipulation using a third variable to swap the number, but I will not be using that, and will be using a inbuilt function swap, which would be taking two argument, that array of I, which should be swapped with the element which is present at array of small index. So we will swap them, but for using a swap function we need to include algorithm library, and it is pretty much all done. And now we need to compile the stuff so that we can know that our array is sorted. So let's start with it. We have this selection sort, we'll be compiling it, running it, and you can see 12, 1, 21, 15, 13, 0, -3. We are having the sorted array using this algorithm. So it is pretty much done, and I hope so all the things are clear. What we are doing here is that we are finding the sorted element for the single index, that what will be the sorted element for index 0, then what will be the sorted element for index 1. Then means to say is that we are finding the minimum element at the first of all we are traversing whole array, finding the minimum element, then we are excluding that element, we are having the whole array again but excluding the first element, and then again traversing and finding the smallest element, and just swapping the smallest element with that position, and that's all done. One more thing is here, that we need to calculate the worst case complexity and best case complexity of the algorithm. So you can see that there is no ending condition in this algorithm, so we are not unable to get that the array which is resulting at the end of the second for loop, after the next iteration in this for loop, is that array is sorted or not. We are not getting that when is the array sorted. So how it will be possible that for the complexities will be different, but the complexities will be same, because as there is no ending conditions. So as you will figure it out, that we are having a loop of size n here, and also the size of n here. So the worst case complexity is n square, and the best case complexity is also n square. And I hope so everything is clear, and if it is clear, please like the video. Thank you. That is all.